Okay, so operations with rational expressions. So here we have multiplication. And so before we multiply, we like to see if we can reduce it. So we need to first factor. So this numerator, I have dots, difference of two perfect squares. So this is x minus 2 times x plus 2. And in the denominator, again, difference of two perfect squares. So we have x plus 1, x minus 1, times, well, nothing to factor here, nor here. And now I look to divide out up and down, or on the diagonal. Well, on the diagonal, x plus 1 divides x plus 1, x plus 2 divides x plus 2, and so I'm left with x minus 2 over x minus 1. Cannot simplify any further, so there is the final answer. Here we're dividing, and we know when we divide fractions, we can multiply by the reciprocal, so we're going to keep, change, flip, and we'll try to factor to reduce also. So 6x minus 2, there's a GCF of 2, and I'm left with 3x minus 1 all over GCF of 6, left with x plus 4. I'll change this division to multiplication. X plus 4, nothing I can do there. 3 in the denominator. Now let's look to reduce, since we now have a multiplication sentence. And so x plus 4 divides x plus 4. 2 goes into 2 once, 2 goes into 6 3 times. And so in the numerator, I have 3x minus 1 all over 3 times 3 is 9. Final answer. Number 3, I am subtracting rational expressions. So in order to subtract or add fractions, we need a common denominator. So this guy has an a plus 1, and this one has, let's factor to see, a minus 2, a plus 1. So my common denominator is this whole thing all together. This one has the a plus 1. He has both of these, so he needs this. So I'm going to take, this guy needs a minus 2, so I'm going to multiply my fraction on the left by a minus 2. And this guy already has a minus 2, a plus 1. So that here we get 2a minus 4 all over a minus 2, a plus 1, minus a minus 2 all over a minus 2, a plus 1. Now we have a common denominator, so I can go ahead and subtract the numerators. So I have 2a minus 4. Don't forget to distribute the negatives. I put parentheses to remind myself. Negative a, and then a negative, and the negative is plus 2. Let's just simplify that right now. 2a minus a equals a. Negative 4 plus 2 is negative 2 all over a minus 2, a plus 1. These guys cancel, so final answer is 1 over a plus 1. Final answer. Here we're adding fractions, so again I need a common denominator. So this guy I can rewrite in factor form so I can see what I'm doing. Plus 1 over x. Well, he has the x, but he does not have this x minus 1, so I will multiply top and bottom by x minus 1, and so I have 1 over x times x minus 1, the guy on the left, plus, well, 1 times x minus 1 is x minus 1, and I have this x times x minus 1 in the denominator. Now that I have a common denominator, I can go ahead and add the numerators. So I have 1 plus x minus 1. 1 minus 1 is just 0, so I'm left with just x in the numerator all over x times x minus 1. X over x can reduce, so I'm left with 1 over x minus 1. final answer. Here I have a complex fraction, so we talked about the LCD method, or multiplying by the reciprocal, the keep, change, flip method. I'll show both. You can use whichever method you're more comfortable with. So LCD, if I put this guy over 1 and this guy over 1, I have my 1, 2, 3, 4 fractions. 1 is my denominator, x, 1 and x squared, so altogether I have at least an x squared. My LCD is x squared. You could also make your LCD 1 times x squared. You can make your common denominator x cubed, and you'll still get the right answer. You will just need to simplify more. But I'll use the LCD of x squared, and so I'll multiply each of these fractions by x squared over 1. This guy, this guy, this guy, and this guy. And so this fraction here, 1 times 1, I just have 1 in the denominator. X squared times 4 is 4x squared. Right? There was no denominator to reduce here. If I take this guy, well, look, this x is in the denominator. If I can cross him out, there's 2 here, so I can take 1 out, and I'm left with x times 1, which is just x. And then down here, well, 1 is in the denominator, so this is just 3 times x squared, plus, look at this here, x squared, and x squared divides out to 1, so plus 2. Can I reduce this anymore? Doesn't look like it, but I'll factor the numerator just in case it's not that clear. All right, GCF of x, all over, nothing I can do in the denominator. So final answer, or either answer is final because they're both in reduced form. Keep, change, flip. Well, remember this was my numerator, 4 plus 1 over x, divided by, in my denominator I have 3 plus 2 over x squared. Well, before I can multiply by the reciprocal, I need to make each of these one fraction. In order to add these guys together, he needs an x. Whatever I do to the bottom, I got to do to the top. And so I have 4x plus 1 all over x, and this is being divided by. Well, here, in order to add these, this one needs an x squared. Whatever I do to the bottom, I got to do to the top. And so I have 3x squared plus 2 all over my common denominator of x squared. Now I can keep, I can change, and I can flip. And now that it's a multiplication sentence, I can try to reduce. X goes into x once, goes into x squared, there's x left over. Nothing else I can do, so I have this guy, put him in front, times my 4x plus 1 all over 3x squared plus 2, final answer, which matches that guy. So either method you can use, whichever one you're more comfortable with.